Welcome to this session on learning operations on a single linked list. We already know what is a single linked list, what is a set of nodes existing in a single linked list, and we also understand that we have a variable first to store the address of the first node of the single linked list, and this first will help us do various operations on the single linked list. We've already looked into the operations of how to create a node, how to insert into a node, be it the beginning or the end or in between, all those variations we've seen. We've also looked into the traversal techniques. What are we doing today? The agenda for today's session is to understand of how to delete a node. We're not looking at just any node which exists, but we are looking at deletion of the first node. So here I have the variable first, store the address of the first node, and we will look at how in my program I could get rid of the first node. Right? This node should be deleted and I should have my variable first updated accordingly. So let's have a variable temp to store the address of the first. So let's have a variable which is initialized to first. So I will have my temp also point to this first. So I understand that this is not node to be deleted. So remember, temp will always hold the address of the node which is to be deleted. So at some point of time, you should be able to say free temp, which does the deallocation. But if I now do free temp right away, this will get deleted and first will not be updated to this node whose data field is temp. So I want in my program this updation also to happen. I would want first to hold the address of this second node which will be the new first node, right? So how do I do it? I say first connects, which is the second node, right? This will give me the second node. So this is what should be assigned to first. So I will say first should be equal to first arrow next. So these three set of lines of code will ensure that I delete the first node. Let's cross check again. I say temp is equal to first, I update my first to the next node, and I call free of temp, which will basically delete this node, right? So this seems to be working when we have 5 nodes, 10 nodes, or a set of number of nodes where the number of nodes is greater than 1. Let's look at a case when this code work when I have just one node. If you could see, this is the same set of 3 lines that we had written, right? So let's check if the same set of lines code will work for a scenario where there is only one node existing. What would happen? Temp is equal to first. I will have temp also hold the address of this node. I will say first is equal to first arrow next. So what is first arrow next? The value of first arrow next is this field. And what is this field? We know it is null. So I will have null assigned to first. And I call free of temp. So null being assigned to first is actually what I wanted, because I understand there is only one node existing, and if I delete that node, my value of first should become null, signifying the fact that there are no nodes in the list. It's an empty list. Case 3. What if the list is empty already, right? What if first is already null? What do I do? Would these 3 statements still work? Let's check. Temp also becomes null because first is null, and I try doing first next. But what is null next? It's something which is undefined, right? So this would lead us to a logical error, and hence I shouldn't be doing that. So this statement wouldn't work. So this third case where no nodes exist in the list is to be a special case which I'll handle in my code, right? All other scenarios of one node existing, 10 nodes or 100 nodes existing, these the 3 statements which we saw would work. So let's complete our code of delete first node. I will handle the exceptional case first. I will say if first is null, tell the user that there is nothing to delete, and then return null. But if there is a first node existing, I will do the task of using temp, incrementing first to the next field, and preempting or deallocating, and look at this fact, I return what is the value first. Why do I do it? I do it for the fact that I understand when I am deleting the first node, if it exists, I am deleting it and there's a change to the variable first, right? And the calling function, in our case, let's say it says main, the main function should know there's a change happening to first, and hence I return first. And if you could see, I put the return type of my delete first node routine as struct start, so that the calling function is well aware of an update happening to the first node. So with this code, we've successfully deleted the first node of a given single.